Good morning, class. Here is some review for test one. Just to put some levity into this, let me show you my dog here. Hey, Duffy. Yeah, you good doggy, aren't you? Good boy. Actually, she's a girl. Good girl. Okay, back to business. Uh, so let's look at this function right there. Given f of x equals 4x squared minus 5x minus 6. So we can do a lot of things with that function, whatever we're asked to do. So I'm asking us to find f of negative 2, which is called evaluating a function for when x equals negative 2. Whatever is in that parentheses is an x value. So let's do that problem first. And then notice the next problem, though, is another evaluating a function, but we're going to let x equal x plus h. So every time we see an x in the original function, we're going to plug in x plus h. That's how these evaluating of functions work. Notice when you have a number for x here, you get a number answer. But for this one, we have an expression, like variables here. So we don't get a number answer. We're going to wind up with an expression as an answer. Okay, so let's do the first one. We want to find f of negative 2. So here it is. F of negative 2 equals. All I'm going to do is plug in negative 2 for all x's. So, and I got to preserve the 4 there. So 4 times negative 2 all squared minus 5 times the negative 2 plus 6. So that's step 1 to fill in correctly. And now let's just simplify this. So always do order of operations. So you got to do exponents before multiplication. So what's negative 2 all squared? Isn't that the same thing as what's negative 2 times negative 2? And that equals a positive 4. So now we got 4 times 4. What's a negative 5 times a negative 2? A positive 10. So you get the sign for free there. And then plus 6. And what's 4 times 4? 16 plus 10 plus 6. And that equals 32 when you add up those three numbers. So that's the first problem done. Notice this function, isn't that a quadratic function? So that means its graph will be a parabola. And what point would be on that parabola? Clearly, negative 2, 32 would be a point on that parabola, just for extra stuff here. I'll even write that down. Negative 2, 32. Because again, this is the x and the output is the y. When you let x equal negative 2, the output is 32. So doesn't that mean that is going to be a point on that parabola? Yes. I could also, if I did a table of values, if I let x randomly equal negative 2, say, since that's what I did over here, what's the output? You plug in negative 2 for all x's in the original function, and you get 32. So indeed, it's a point on the parabola. So this means the same thing as that. It's the same idea as this. That equals 32. Okay, let's do same function, but this time we're going to let x equal the weird x plus h, which is an important thing because the difference quotient involves this idea. So what does f of x plus h equal? It's going to equal, and go back to the original function, and I'm going to plug in x plus h for all x's in the original function. So I'm going to preserve that 4. So I even let this x be x plus h. So f of x plus h equals 4 times x plus h all squared minus 5 times, what am I going to plug in for that x? X plus h, and then that's just a constant, so rewrite it, minus 6. So that's a good first step here. And let's go ahead and simplify this. Don't stop here. Let's keep going. So that equals 4 times, again, you got to do order of operations. Square that binomial. This is 2 terms called the binomial. We want to square it. So square out the binomial and then multiply it with that 4. So what does x plus h all squared equal to? Squaring a binomial comes up a lot in math. There's 2 ways to handle it. One's the shortcut way. Shortcut way is just 3 steps. Square the first term, that gives you x squared. Second step, multiply these 2 terms together and then double it. So what's x times h? xh, and what's that doubled? 2xh, and then square the third term, and you get your h squared. So squaring a binomial is harder than it looks. Notice you get the 3 terms here. You get or you could have done it this way: x plus h all squared equals Isn't that the same idea as you take that base, x plus h, and multiply it to itself twice, since that's the exponent? That's what this means. This is the base and that's the exponent. This means multiply the base to itself that number of times. So now we got a binomial times a binomial, and we know how to FOIL. First, outer, inner, last is FOIL. What's x times x? X squared. Outer, what's x times h? xh, so I'm going to write plus xh. And then inners, what's h times x? xh or hx, but might as well write xh. Multiplication's commutative. Doesn't matter the order. And then the last, what's h times h? That's going to be h squared. And then combine like terms, which happens so often when you FOIL. And these are like terms because it's the same letters or variables and the same exponents, 1, 1, 1, 1. So let's simplify that. That's going to equal x squared. And isn't that just going to become, you add up the coefficients when you add up like variables. Just an assumed one coefficient here and a one coefficient here. So add up the coefficients and you get gives you 2. And then keep the letters and exponents exactly the same. And then plus h squared. And isn't that the same thing that we got over here? Yes. Shortcut is a little faster. Okay, now let's continue. What's a negative 5 times the quantity x plus h? This is the distributive property. What's negative 5 times x? Negative 5x. And what's negative 5 times h? Negative 5h. And then minus 6. Let's continue simplifying. Let's use the distributive property here. I got to take that 4 and multiply it by all 3 terms in the parentheses. So that gives me 4x squared plus 8xh plus 4h squared, and then minus 5x minus 5h minus 6. There's no like terms here, so that's the final answer. We are done. Looks like 1, 2, 3, 4, 5, 6 terms there. Wow. And none of them are like terms, so that's the final answer for that one. Okay, let's find the x-intercept for the same function. Look at all this work we're doing with the same function here. First, we evaluated that function for when x randomly equaled negative 2, and we got that output. Then we let x randomly equal x plus h, and we got that output. Now I want to know, what are the x-intercepts here? How do you find the x-intercepts? You let y equals 0 and solve for x. You always do that for an x-intercept. It doesn't matter what the function is. Even if it's a logarithmic function, same idea. So it's good to know that because intercepts will follow you throughout the rest of your mathematical careers. So let's let y equal 0 and solve for x. So I'm going to write 0 equals 4x squared minus 5x minus 6 right here. And what's the best way to solve this? Well, hopefully it's factorable. It's easier to factor than use quadratic formula. And this is factorable. What two things multiplies to 4x squared? This is tougher since the leading coefficient is not 1. So it's trial and error I'm using here. I know that 4x times x gives me 4x squared. It could have been 2x times 2x though. But you say, what two numbers multiplies to negative 6? So that's a 3 and a negative 2. That works. It could have been negative 6 and positive 1. That's why it's trial and error. But you don't say it adds up to negative 5x. You only do that when the leading coefficient's 1. That's why these are harder. Anyway, I did this problem in advance, so this is indeed correctly factored. Always check your factoring to make sure it's right, especially when that leading coefficient is not 1. See, 4x times x does give me the 4x squared. And then if I multiply the inner terms, what's 3x times x? 3x? I'll write that there. And then multiply the outer terms. What's 4x times negative 2? Negative 8x? I'll write that here. Always add them up, and what does that give you? Negative 5x? And is that the middle term? Yep. So it is factored correctly. Or you could just FOIL it and see if you get back here again. And now, let's use the zero factor property. Whenever you have something times something equaling 0, it's very powerful. That means one of these factors has to be 0 or both. So to make this a true statement, just say this factor equal to 0 and that factor equal to 0, and you get your x's that way. So I did the first factor equal to 0. I got x equals negative 3/4. And that's not just any x, that's the x-intercept, because didn't we let y equal 0? Yes. And then set this factor equal to 0. You can tell by inspection it's x equals 2. And I wrote them as ordered pairs. Negative 3/4, comma 0, and 2, comma 0. Those are the x-intercepts. How do you solve for a y-intercept? It's the flip-flop. You let x equals 0 and solve for y. It's usually easier to find the y-intercept. So let's let x equal 0. I'll even let that x equal 0. So I write f of 0 equals 4 times 0 squared minus 5 times 0 minus 6, which I have right here. I let all the x's equal 0, and now let's do the math. That's going to be 0 minus 6, and doesn't that equal negative 6? Or as an ordered pair, 0 comma negative 6. Make sure you write the ordered pair correctly. A y-intercept means, by definition, the x coordinate is 0. So that is the correct ordered pair. Well, we got a lot of key points there. We found some points there. We could probably do a pretty good job of graphing this parabola just with only these limited points. Of course, it'd be nice to find the vertex, which comes later on in the course. Anyway, that's a quick review for test number 1. And I did put some stuff on Learn, for the lesson plans. So check out announcements, and you'll see a couple of lecture notes. All right, everybody. Hope you're all doing well, and see you next time.